looking forward for pandemic situation improving. So tonight we have an introduction, news and updates from OWASP. We'll tell you about the latest conferences, projects, and new tools available at OWASP. Then we will have Anastasia presenting her talk on cryptographic protection of machine learning models in mobile apps, followed by a Q&A session. And then we will have Mark talking about how to be better at InfoSec and 10 lessons learned from moving from the dark side to the light. And we will have another session of Q&A and some closing remarks. So quickly about us. So my name is Sam Stepanyan. I'm one of OWASP London chapter leaders. We have Andra and Sharif as co-leaders. If you are going to tweet about this event tonight, please use #OWASPLondon hashtag. And you can also find us on Twitter at OWASP London. Usually at this point, I talk about OWASP, what it is and how it works. But let me now play a video that we now have, which will briefly tell you about OWASP, its projects and member benefits. Yes, that's OWASP, our worldwide free and open source community with our mission to make security visible so organizations can make informed decisions about application security risks. And of course, this is all free. One important thing to notice about OWASP and OWASP membership is that there are board elections happening right now at OWASP, and if you are a member, you do have your right to vote, which is quite important. The board elections started in August from the call for candidates. You can see the timeline on the screen right now. The names of the candidates will be emailed to everyone shortly, and the voting will open on the 15th of October. So please make sure that you have your OWASP membership renewed if you have OWASP membership already. And if you are not an OWASP member, of course, urge you to get OWASP membership and become a member. Of course, you've seen the benefits of it. And there is one new benefit that I'm going to announce very shortly. And again, going back to the elections, the voting will start on the 15th of October, and it will last for 2 weeks. And the results of the elections will be announced on the 1st of November, and we will find out the names of the new board members. So we have a brand new benefit for OWASP members, and that is an Application Security Foundations training course, which has been kindly provided by We Hack Purple, and here you can see Tanya Janka is the creator of the course from the We Hack Purple Academy. Usually this course is $500, but it is absolutely free for OWASP members. So yeah, that is a great benefit, which is now added to our list of benefits. And speaking about membership, the membership costs $50 per year. Students get a discount, so students pay $20 per year. You can also become a corporate supporter. Your company can become a sponsor of OWASP, and currently there is a corporate membership drive to celebrate OWASP's 20th anniversary. So there will be discounts available for organizations if you wish to join OWASP as a corporate member. And also there is currently a discount of 10% for anyone who wants to become a lifetime individual member. That means you only make one payment, and that's it. You don't have to make any annual payments. You will become an OWASP member for life. Of course, OWASP is a vendor neutral community, but we are of course, supported by various organizations all around the world. And you can see the names and the logos currently on the screen. These are the companies who are kindly sponsoring OWASP and helping us to produce free documentation, guidelines, standards, and tools, and of course, organize meetups. For us in London, we have sponsors as well. You can see their names on the screen. I'd like to thank them very much for supporting OWASP London. And if you would like to support us and see your company logo on this page, please do get in touch. Another new thing at OWASP is a new tool for OWASP members. We now have an OWASP membership portal, which looks like this. It's very simple, but it allows you to actually manage your OWASP membership account. You will be able to see the date of expiry of your current membership. You will be able to renew your membership. You will be able to use the QR code shown to prove your membership, because of course there are various conferences and events which will give discounts to OWASP members, and that's how you will be able to prove your membership. Also, the membership portal will also show you the status if you're a leader, if you're a project leader, if you're a chapter leader, or if you participate in any of the OWASP committees. Another new thing is that OWASP now has a merchandise store. Yes, you can now go and order your OWASP hoodie, OWASP baseball cap, and lots of other merchandise. And of course, because this year is the 20th anniversary of OWASP, there's quite a lot of merchandise available with the 20th anniversary logo on it, which you can go and order. The OWASP merch store is based on Zazzle store. So the don't forget that the price that you pay includes donation to OWASP Foundation. So one of the interesting pieces of merchandise available, of course, there are OWASP face masks. And yeah, I think quite an important thing in our current age of pandemic. The big news on the events front for OWASP is that, of course, we have our fantastic 24-hour free online conference dedicated to the 20th anniversary of OWASP. It is celebration. Next Friday, 24th of September, OWASP turns 20 years old, and we're going to have a conference for 4 tracks, fantastic keynotes, lots of talks on different topics, including mobile security, cloud security, the future of application security, from fantastic speakers. So please do join. It is all absolutely free, but you do have to register to be able to watch the stream live and also to access the recordings later on. So if you haven't registered yet, please do go to 20thanniversary.owasp.org and register for this fantastic event, which is coming up. Another big conference coming up is AppSec USA 2021, which is going to be virtual this year again, just like it was last year. The registration is now open. And another important thing to mention about AppSec USA is that the sponsorship opportunities for it are now open. So if you represent a company and your company would like to sponsor OWASP Global AppSec USA conference and have your logo displayed at various places during that conference, please do get in touch, because on the website, on the usaglobalappsec.org, there is a link with a sponsorship pack where you will be able to choose a sponsorship pack suitable for your company and make sure that you support this fantastic event. Another great event coming up, again, very soon, is OWASP Lightning Conference. So OWASP Lightning Conference will be on September 28th at 8 p.m. London time. And this time we have Caroline Wong speaking on the future of security and cloud native. Again, it's a free event. All you have to do, just go owasp.org, click on Lightning Conference, and then just register to be able to join that session online. That will be, I believe, live streamed using Zoom. Another great event which is currently happening is virtual training. If you would like to train your staff on topics of application security, the next OWASP official virtual training is going to take place in November, on November 16th. The courses available will be on the applied data science and machine learning for cybersecurity, quite a hot topic seems to be, and we have a machine learning related talk tonight as well. There will be a training on the how to improve your SDLC using OWASP SAM, and also training on automating security in DevOps world and DevSecOps, as well as security for your developers, the offensive approach. So if you'd like your developers to learn application security straight from OWASP trainers, that virtual training event is now available for registration, and you can see the prices online. And as usual, if you are an OWASP member, there is a discount available to you. Another event I'd like to mention is Open Security Summit, which is actually happening this week. It is virtual, so there are quite a few sessions that you can see on the screen. You can join them live using Zoom, and all the recordings are available on the Open Security Summit's YouTube channel. Of course, another important thing for OWASP is OWASP projects. We have well over 200 free and open source projects available to you. There are now 20 flagship projects, and I'd like to bring your attention to a interesting project called OWASP Spotlight Project, which is basically a YouTube channel where OWASP board member Vandana Verma is interviewing project leaders of various OWASP projects. There are quite a few videos available there already, where in 10 to 15 minutes, you will get all the information you need about particular project, what makes it great, how to use it, how to contribute to it. Definitely do go and check it out. And of course, the big announcement and the big event that everyone has been waiting for this year is the brand new OWASP Top 10. And it's just been released, the new draft. It is still not the final version. It is currently available for the review, comment, and translation. It is on GitHub, so please do check it out. Quite a lot of things have changed this year. Some of the vulnerabilities and risks, they've been aggregated. Some new ones appeared. For example, you can see that server-side request forgery or SSRF is there. And then also some more generic categories which appeared on the lists. Things like insecure design, for example, is now OWASP top 4 risk that you need to consider. So definitely do check it out. It's now available on owasp.org/top10. And I am very pleased to announce that At our next OWASP London chapter virtual event, which is taking place on October 7th this year, so only in a few weeks' time, I'm pleased to confirm that Andrew van der Stok, OWASP's Executive Director and also the project leader of OWASP Top 10, will be here, and he will be talking about a new OWASP Top 10. We'll be answering your questions about the reasoning for the new top 10 most critical vulnerabilities. So do make sure that you register and do not miss that event. Moving on to our talks, to remind everyone that today you will be able to ask questions. Please do use the Q&A facility. And if you have a YouTube account, please do ask your questions using the YouTube live stream, YouTube Q&A. If you don't, just go to slide.do/OWASP. We're using the slider system where you will be able to ask questions anonymously if you want. Now it is time for our presenters. And the first talk tonight is cryptographic protection of machine learning models in mobile apps, presented by Anastasia Voitova. And she's joining us from Kiev, from Ukraine. Anastasia is a head of customer solutions at Cossack Labs, and she's a software security engineer with over 10 years of experience. She specializes in security engineering, data security, and applied cryptography. Anastasia is a prominent leader in the Ukrainian cybersecurity community, and she's also a co-leader of Women Who Code Kiev. She also maintains an open source cryptographic library called Themis, which is quite an interesting one, and I hope she will be able to talk about this later tonight. She also conducts secure software development training, and she speaks at many international conferences. And I believe the last international conference that Anastasia visited in London actually was QCon London a couple of years ago. Okay, so now we're ready for Anastasia. I'm going to stop sharing my screen and welcome her. Hi.
Hi. Yeah, thank you for all these kind words.
Welcome to OWASP London. As we already chatted earlier tonight, the weather in Kiev is much colder than what we have currently in London, but that doesn't stop us cybersecurity professionals to join online events and trying to learn from experts all around the world. So please do share the screen, Anastasia, and share with us your talk.
Yeah, I'm already sharing the screen. I think that everything is fine, right? So yeah, and Sam, as you mentioned, OWASP will have so many great events coming up. And also I'm super excited about new updates in Top 10. I would like to emphasize cryptography, that cryptographic failures now is Top 2. So yay! So if you understand that you struggle with cryptography, just for I'm working in a company that does a lot of cryptography related software and tools. And tonight our topic for the talk is also related to cryptography. So let's get started. I'll try to do it fast and interesting. And if you don't have any cryptographic background, no worries, we won't go deep inside ciphers, no math. So just relax and enjoy. As we mentioned, cryptographic protection of machine learning models. Yeah, my name is Anastasia. My nickname is Vixentail, and I'm a security software engineer. I do a lot of things related with data security, with cryptography, applied cryptography. I say applied cryptography, meaning that I am not the one who will design new ciphers, well, at least not now, maybe later, but I'm the one who definitely implements the cryptographic layer in the software, right? Design some end-to-end encryption protocols, or just make sure that cryptography is well implemented. And tonight we're going to talk about a hype topic, ML and security. Unfortunately, as is a hype topic, there are a lot of different connected issues. So this is the list about things we won't cover today. We won't talk about adversarial networks. We won't talk about, all these shiny holographic stickers that you can put on a stop sign for automated car to recognize the stop sign as different sign. We won't talk about that. We won't talk about machine learning, like unlearning mechanism, which is really interesting. So I encourage you to check out the links after my talk. We also won't talk about malware inside machine learning networks. Sorry, topic for another day. Also sounds exciting. And of course, we won't talk about TensorFlow bugs. They have a lot of bugs, and recently another one was discovered related with YAML format serialization, deserialization. Not today. Today we're going to talk about a little bit about TensorFlow. Again, if you don't have experience in machine learning, no worries. I am also not a machine learning engineer. We're gonna talk about like security from more like high level perspective. We're gonna talk about a lot about cryptography, how to construct the encryption layer, and we're gonna talk about different traditional security controls, like integrating cryptography into existing security controls or building security controls around cryptography, like API protection, like cloud storage protection, mobile application protection, like reverse engineering protection, things like that, because cryptography doesn't live in a vacuum. And every time when you need some ciphers, when you need some crypto, you need to understand that it's a real life, and just cryptography is not enough. So let's begin. Basically, a case that I will explain tonight, I cannot say that it's real life because I should not say that, but it might have happened. And imagine that there were companies that had machine learning techniques in their mobile applications. So they have pretty popular mobile applications for iOS and Android, and they used a lot of machine learning to do something for their users. Let's just say theoretically, they ask users to submit their photos, and then they use machine learning to put like cat ears on user pictures, things like that, right? So the talk today is going to be about protecting those machine learning models because that company changed their data flow. Previously, they were using like classic backend processing, right? So mobile applications send these pictures to the backend, and backend had a huge machine learning model that was doing all required computation and then sent results back as a picture to mobile applications, right? So all IP, all machine learning related things were happening on the backend side. But then this company decided to change this flow because obviously cloud processing bills were increasing as when they have more and more users, and they wanted to offload some resources from cloud side and put those resources to mobile applications. So the new suggested flow was let mobile application send the picture, backend would prepare individual machine learning models that I will call tonight IML, and send this individual machine learning model back to the client side, back to the application side. Then application itself would run machine learning processing, and application itself would put those cat ears on people's faces, right? So instead of having one huge machine learning model in the backend, this approach allows to have smaller individual machine learning models on mobile applications. And as both iOS and Android support TensorFlow, that sounds like a good deal. However, security questions arise. What are the risks of the decision? As this talk tonight, that's mostly cryptographic talk. I won't go deeply inside threat modeling, but just, to give you like from bird's eye view. The most important business risks were losing those individual machine learning models, because one small individual machine learning itself is not an issue. They're highly customized per user, right? But if some attacker decided to collect many machine learning models, they could theoretically understand how technology worked and recreate this huge original machine learning model. You know what I mean? So what we are protecting here is this small individual machine learning model that backend now sends to millions and millions of users and mobile devices. Obviously, another, so this is like the most important risk here. Obviously, another risks include abuse of infrastructure, meaning that someone can create a script to ask for many of these models, do some kind of try to do some kind of denial of service of the backend, asking again for more and more of these models, which will lead to obviously losing revenue, potentially reputational risk, yada, yada, yada. But the main idea was that the company should not, the company tried to avoid leaking many of those individual machine learning models. Let's talk about technology a little bit. What we have here is native mobile applications, iOS and Android. Native meaning that languages used for Swift and Objective-C for iOS and Kotlin for Android. And of course, the machine learning frameworks, which is CodeML on iOS and TensorFlow Lite on Android. From the backend perspective, the case has Python backend, TensorFlow, and any cloud. In our example, I use Google Cloud Platform, right? So workers, storage, KMS, Firebase, databases, everything in Google Cloud Platform. And this is how the simplified data flow look like. As we are not interested in protecting all the things, right? Let's have a focus here. We're interested only in protecting individual machine learning models. And this is on the scheme, we see the data flow, the life cycle of the model. So the models are generated on the backend in Google Cloud, like in a server on a worker side, right? Based on some user input, based on some user data. Then these models are being stored on Google Cloud Platform storage. And then mobile applications through API can gather those models and put them on the mobile side. The important thing here is all this happening in real time and all this happening per request. Like so, right, so user presses a button, the mobile application makes a request to the backend calculates this individual machine learning model, stores it at the file, the Google Cloud Platform storage, and API responds back to the mobile application, the URL, the link to the model. And of course, when we have these individual machine learning models like separated, stored in the infrastructure like that, we can build the life cycle and we can analyze what are the risks, what are the threats, where is this machine learning model, what's the data flow, what parts of what components of the system it goes through, right? As we mentioned, it was generated on the worker side, on the server side. So obviously it appeared in the memory of the worker. Then it goes through a transit to the storage. Again, it appears on the storage, right? Then it goes through the API, and at last it comes to the mobile application. So we have all the possible options here, all the things at once, storing in memory, storing in transit, storing on the storage, and this model just appears almost everywhere. From threat modeling perspective, again, this very simplified threat modeling. We say that as our model appears almost everywhere, there are different kind of threat vectors, right? For example, leakage through API, leakage through storage. Imagine that model lives there forever, won't be good, right? Leakage through eavesdropping, and of course, insecure storage on mobile application. Imagine when your application is so popular that it has millions and loads, literally, that someone will decide to crowdsource the models, right? That some competitors will ask your users to gather these models and send to competitors. So we don't want that, definitely. We want to protect the model on mobile side as well. And we don't trust users at all. In terms of Stride, threat modeling, we are mostly interested in spoofing, tampering, disclosure, and denial of service, which mean that protection methods that we can have is to make sure that data authenticity, integrity, and confidentiality won't be touched, right? Availability, I mean, cryptography won't help with availability too much, but it can definitely help with C-out, re-out. So let's use cryptography because, as we mentioned previously, our individual machine learning models are stored everywhere. The data flow looks huge, and it's going to be really good to have super nice security control that we can use once the model is generated and until the model is executed. But before we dig into cryptographic part, let's talk about what is machine learning model, what kind of thing we are trying to protect here. Disclaimer, I am not an ML engineer, okay? So from my very naive look, machine learning models in our examples, they are just files. I mean, yeah, they're very specialized files. Yeah, in this example, they had layers, and every layer had weights, like numbers, right? Weights. But from security perspective, it's still just file. Everything is simple when we're trying to protect files. So how to build the encryption layer? As we mentioned previously that machine learning models are being generated on the backend side, the obvious solution is to encrypt them right before generation. So trying to decrease the lifetime of plain text model, encrypt them on the generation side, store them encrypted all the way until you put this model to the mobile application side and then decrypt them on the mobile application side. So encrypt once, decrypt once, right? Looks like a symmetric scheme to me. And indeed, let's take a look on the requirements, how we would formulate the requirements for this encryption layer. First one is obvious. Let's try to minimize the lifetime of plain text individual machine learning model file. We want to store it in plain text as tiny amount of time as possible. Then let's try to minimize the chance of someone accumulating these models, which means that it would be nice if every model would be encrypted using different kind of keys, because then brute forcing those keys would be pretty long, right? And of course, as we're talking about mobile applications and as we're talking about Python backend, it would be really nice to have fast, smooth cryptography, industrial proven cryptography. So yeah, in our example, we're gonna use just IIS, GCM, and Elliptica Diffie-Hellman for key exchange. No fancy things, no Blake, no Argon, very industrial proven, very traditional cryptographic ciphers. And number 4, it would be really nice. Imagine the amount of these models, imagine the amount of mobile application. It would be really nice to live without public infrastructure. What I mean is that when you have so many users, when you have such large load, the good idea would be not to store public keys of everyone, because good PKI is a very expensive PKI. Building public infrastructure is really expensive, long and complicated journey. And sometimes if we could avoid it, this is a good thing from cryptography perspective. Not the best maybe from security risk perspective, but in our case, using ephemeral keys, ephemeral means temporal, using temporal encryption keys, avoiding building a complicated PKI was a good choice. And obviously all these things should work on the platforms that we selected. And it might be tricky with cryptography because often when developers try to use cryptographies, they use their native language, native library available in the language they're using right now. And sometimes when they realize that thing that they encrypted on one platform should be encrypted on another platform, and cryptographic libraries often have quite incompatible APIs. To solve that, fortunately, good libraries exist, and we used one of them, Themis. It's also possible, I will show an example later, it's also possible to use Lipsodium, basically use multi-platform cryptographic libraries that are built for your target platforms. Let's take a look about cryptography a little bit deeper. So, in our example, remember, we have a backend that will encrypt machine learning model, and we have mobile applications that will decrypt machine learning model. To do that, and we use individual keys for each model. To do that, we're gonna generate key pairs on each side. So mobile application will generate its key pair and it will send its public key to the backend side. Backend side will generate its key pair as well. Then backend side will perform elliptic curve Diffie-Hellman and generate a shared key. Then backend side will generate random data encryption key, which we are calling DEK, D-E-K, data encryption key. Then backend side will encrypt the model using data encryption key using IRGCM. Then, right, so data, we got data encrypted, but so we still have a key. Then backend side will encrypt the encryption key using pre-generated shared key, again using IRGCM. And then we have the package. We have encrypted model, encrypted key, and server public key. And this package is what was stored on the Google Cloud Storage, and this package is what we sent back to the mobile application. On mobile application side, mobile application takes its own private key from previously generated key pair, right? It takes server-side public key from the response from this package. It uses the same, it does the same operation. It uses elliptic curve Diffie-Hellman to generate shared key. Then it uses IRGCM decryption with shared key to decrypt data encryption key. And then it uses data encryption key, IRGCM to decrypt the model. Very simple, super straightforward. And the good idea that these keys are ephemeral. So this data encryption key, it was used once for only one model. Next model will use another data encryption key. For next exchange, both parties can generate another key pairs. You know what I mean. So the format of individual machine learning model, again, super straightforward. If we put it into JSON, it would look something like that. By the way, this is just like a real JSON here. I mean, what you see here is a data field, which is our encrypted model, right? A key field, which is encrypted model key, public key, which means server-side public key from key pair. And I call it ephemeral again to emphasize that this key can be changed on another generation. Of course, versioning is very important. When you use cryptography, when you encrypt something, please put a version there, because sooner or later, you would like to change your cryptographic cipher or your approach, and versioning will really help you here. So obviously we will put version, and we might have even more encryption inside the layers of machine learning model, but just remember this thought, I will come back to it later. So technically, when we're encrypting, let's make a step back. When we're encrypting machine learning model, we can do it as a file, and we have encrypted the model. We use ephemeral key, we encrypted the key, and everything is based on key exchange first. And this is how the code looks like, and this is Python code. And yeah, while it may look like a pseudocode, I think it's actually like real Python code. I think the thing is compilable, except probably the last line. And the reason why the amount of cryptographic code is so low, so small, we have only, 12 lines here, right? The reason is because we're using library. Like we use, in this example, we use Themis library, which is like boring crypto library, which has very simple API. And as you can see, developers don't need to handle this huge amount of cryptographic code when they want only to encrypt the data. So in this example, we generate a server key pair with private key and public key, easy. Then we generate this ephemeral data encryption key, cool. Then we encrypt the model, awesome. Using previously generated ephemeral encryption key, we can make encryption even more strong if we pin this encryption to user entity. And in this example, I put user ID here, which means that to decrypt this model, you need to know not only the key, but the user ID as well. Otherwise, decryption will fail. And then we use elliptic curve Diffie-Hellman to generate to generate shared key and to basically encrypt our data encryption key one more time, to encrypt our data encryption key. And this is the package, and this is what we sent on the mobile application side. Mobile application code looks pretty much similar. And this one, backend only encryption, right? So backend doesn't care about decryption. Obviously, in tests, developers obviously have tested that their code can be, that results can be decrypted, but technically production code doesn't need any decryption side. Mobile applications, in this example, iOS. This is an example of iOS code, and again, it can look like pseudocode, but it's a Swift, more or less compilable code. What is happening here? Pretty much the same. We generate a key pair for mobile application, private and public key. Then we use elliptic-curve Diffie-Hellman using server-side public key and mobile application own private key to generate shared key to decrypt encrypted data encryption key. Then we decrypt the model, we decrypt the data. So how many? 10 lines of code, right? And we have the encryption layer built. I'm telling you, cryptography is easy when you use proper tools for that. We used TMS. Disclaimer, yeah, I'm one of the maintainers of TMS. But the library is free to use and open source, and basically this is one of the boring crypto libraries. Libsodium is another example of boring crypto libraries. Tink, I think, can be named as another example of boring crypto libraries. Why we call them boring crypto libraries? Just because using them is very boring. I mean, look at that. No exciting cryptographic things here. Everything is super straightforward. No need to think about ciphers. No need to think about how large the key should be. How should I generate init vector? What nonce? What padding? No need to think about all the things. Just use API, call encrypt or decrypt, and you're good to go. The idea is behind TEM is that this is the same code base, and it has basically the same API across 14 platforms and languages right now. So yeah, it's just guaranteed to work, to be compatible across all those APIs. An example that we use right now with all this approach, right? How we encrypted the model, how we decrypted the model, all this approach is called application level encryption. And this is another buzzword. And this is pretty novel buzzword. So if you hear it right now, remember that, because I expect more and more articles and conference talks and hype things are happening with this buzzword. Because application level encryption, that's very straightforward. Application is responsible for encrypting and decrypting data, right? Application level encryption, obviously, it works together with TLS. So all this encryption doesn't mean that you don't need TLS. No, you still do need TLS. But the idea is that you encrypt the data when it should be encrypted. And you store it encrypted all the time. You put it in your database encrypted. If this data is suddenly being logged, because everything can be suddenly logged, all right, the log will have encrypted data, no leakage. Database will have encrypted data. All the cache is going to have encrypted data. So you encrypt the data and you store it everywhere encrypted until the point you want to decrypt it. Super easy, super straightforward. Of course, it comes with performance penalties. Of course, it comes with kind of limitations. And of course, for example, search. And of course, there are ways to overcome these limitations. But the example that we use right now, the approach that we use right now is known as application level encryption. If application is client side, it's known as client level encryption, right? If application is the backend, like server, it's server side level encryption, proxy side level encryption, gateway side level encryption, whatever. If it's happening on the application's data ends, it's known as end-to-end encryption. And often people say that end-to-end encryption means involving a human, but it might be not the case. It's not always the case. If you're interested in application level encryption, there is another link to large article. another buzzword, another thing I want you to know, the approach we used with this encrypting data with one key and then encrypting key with another key. This approach, it's not new, but now it has new buzzword term, HPKE, hybrid public key encryption, meaning that, again, the scheme is not new. It just got the RFC, and right now I believe there are like 12 drafts in this RFC, and if you're curious, take a look. Basically, this RFC tries to standardize things that many security engineers and cryptographers are already doing. So the goal of RFC is to put the term HPKE and to describe different approaches for this multi-layer encryption. Because right now the terminology is very different. You can hear the things like key roping. You can hear, key roping, I think it's one of them. Envelope encryption is another of them. So yeah, I hope that maybe in a year or two, when I will say to people like, hey, we're using HPKE version 1.1, everyone will understand what I mean and what exactly keys we used. But let's see. So yeah, if you're curious about all this multi-layer encryption happening, check out the RFC, the draft of RFC, because it's explained different approaches. In our example, we used symmetric, and elliptical Diffie-Hellman. But it also can be used symmetric, asymmetric, so different mixes are possible. Let's get back to our case. When we encrypted the models and decrypted the models, let's talk a little bit about key management, because, encryption is easy, key management is hard, right? In our example, key management was not so hard because we used very lightweight approach. We generated ephemeral key pairs, we generated ephemeral keys, almost no need for PKI, almost no need for all these key management procedures described in NIST guidelines, like generation, revocation, expiration. I don't remember all of them. So yeah, of course, with the ephemeral key pairs, the good things that we don't need PKI, the bad things that authenticity problem can arise, right? Think about man in the middle. In this example, we don't solve this problem using cryptography. We solve this problem using different ways, like TLS pinning, like server attestation, things like that. If you want to, so the improvement or like another flavor of the scheme would be to build PKI, basically to pin public keys of mobile applications and the backend. This will help to solve authenticity problems. This will help to understand from mobile application that, yeah, this is exactly our service side we were supposed to talk to. And of course, mobile applications are great to do different kind of cryptographic computations because they have keychain and key store and like secure key storages, right? And in some cases, those keys can be bind with biometrics. So all cool. But as I previously mentioned, cryptography doesn't live in a vacuum, right? So obviously the scheme alone is not enough. Let's make it a little bit more complicated, but of course more and more exciting. First of all, what we want to do is to re-encrypt the models, meaning that when application received a model, this model was encrypted using server-side private key, right? Application doesn't want to store server-side public key. Application does want to re-encrypt the model using, again, IIS, using some other key, just to unpin, just to, unbind from backend keys, not to store backend keys. Yeah, as I mentioned previously, re-encrypting the model on the mobile application side. Let's move. Bonus points if you use different mobile application libraries and bind those encryption keys used in re-encrypting to biometrics, but it's sometimes not possible because biometrics authentication affects UX. So sometimes we don't want users to know what is happening, but it depends on the risk model. the second layer of our defense in depth. Take a look on this timeline. The timeline of individual machine learning model. So it starts from right to left. Yeah, it's a bit confusing. From right to left. It starts with a backend worker that has generated our model. And this is small amount of time when the model is in plain text, right? Then this worker has encrypted the model. Awesome. The model is encrypted. It's been transferred. It's been stored. It's been transferred again. It's encrypted until it gets to the mobile application, which decrypts this model. And of course, we won't store decrypted data. What's the point? Mobile application re-encrypts this model. And still, the model needs to be in plain text before being executed, right? So this execution bit, it kind of ruins all beauty of our flow. We tried so hard to have model encrypted as much time as possible, but still the CoreML and TensorFlow, those libraries push us to use plain text models because they don't know how to deal with encrypted models. No one knows some custom ideas to encrypt those models. So if you're using CoreML on iOS side, how we can help with that? If you're using CoreML on iOS side, actually Apple have docs on different ways to encrypt machine learning models in a way that CoreML will understand and decrypt this model before executing. This is option number one. Option number two is to create custom layers, right? So in our model file, we have layers and we create a custom layer with encrypted weights and decrypt those weights in a runtime when the model is being executed. You know, it's encrypted and then the layer inside model encrypted. This encryption will CPU, so it will affect CPU. Another approach is even more complicated, to use custom shader functions to obfuscate weights before executing on the shader on the GPU side, right? So we need to go deeper. Think about that. Machine learning model file encrypted, layer encrypted, and then some weights can be obfuscated. Unfortunately, I say obfuscated because GPU shaders on mobile applications, typically they are not powerful enough to handle normal traditional encryption algorithms. So we're talking about simple obfuscation, simple kind of mathematical procedures that we can do with this weight on the GPU layer. Yeah, as I put here as number one. When we're talking about performance, typically is that can process machine learning and can render machine learning model, the result of machine learning model on the screen. Probably this device can run cryptography without it affecting user experience. Because ISGCM has hardware support for many years already, and all these modern mobile devices have special chips to run ISGCM, so no issues here. Typically, like modern cryptography, especially traditional cryptography like IS, it's not, it won't cost you as much as you might expect it to cost. It's very cheap. It's very cheap. It doesn't have if you do. Of course, it can be complex. I mean, it can be slow, but it depends on, programming skills. But mostly users even won't see the delay if you do everything correctly. Now, we just finished with encryption layer. It works fine. We have encrypted our models during the whole life cycle. But as I mentioned previously, cryptography doesn't live in a vacuum. So let's talk very, very quickly about the different traditional security controls that we can put into our data flow, into our infrastructure to support our cryptographic layer and to create yet another defense in depth layering happening. So in this scheme, I put it very roughly. For application sides, for example, we're talking about obviously all the application security, all the OWASP, MSVS things. And we are talking about reverse engineering protection because our models are stored on the application side. We want to protect our applications from too curious users, right? On API side, on the backend side, obviously we should have all this authentication, API security, traditional application security, and it would be really nice to have some kind of anti-fraud system, which means that if user asks like too many questions, if user application tries to generate too many individual machine learning models, this anti-fraud system can calculate like fraud level. I will talk about this in 2 slides. And what else? On storage layer, obviously, when we store these models, we want to make sure that we won't store them forever, right? And we want to make sure that access control lists are fine. I mean that these models are not publicly available because that would be unfortunate. On worker side, login, monitoring, traditional application security, all the nice things. So really quickly, cloud storage. As I mentioned previously, we want to make sure that we don't store our models forever. We can use TTL in the URL, right? Modern cloud storage services support them. AWS supports TTL, Google Cloud Platform supports TTL. Easy. Obviously, it would be nice to use some kind of authentication there, so a link is not accessible publicly, right? It would be very nice to clean up our models, make sure that these models won't be part of our regular backups, yada. Basically, treat them as sensitive data. Treat them as, I don't know, user passwords, you know. And you probably know that OWASP Web Security Testing Guide, they have a special chapter related to AWS S3 because people often misconfigure S3 buckets. So yeah, OWASP has a special like guidelines how to make sure that if you store something on a cloud in a public, it doesn't appear in a public bucket. Next, API protection. You know the drill. You know all this authentication things, limit throttling, firewalling, yada. I would like to like basically all the OWASP ASVS, right? It has how many? So like 150 different security requirements. No need for me to talk about all of them. I just want to talk a little bit about anti-fraud system. The thing that I mentioned previously is that it would be really nice not to send, even not to generate individual machine learning model for users that are known to be malicious. You know, how we can understand that users are malicious? We can grab different kinds of events. Some events can be generated by mobile applications. Some events can be generated by backend. And based on these events, our anti-fraud system can calculate scoring. If user is good enough, if user is suspicious, or if we believe that user is malicious. And depending on the scoring, we can, like on a backend side, we can change the behavior of our system. Obvious idea is not to send, not to generate individual machine learning models to users that we believe are malicious, right? To limit sending these models to the users that we believe are suspicious. So we cannot know for sure. We can limit like 5 models per hour or any other metrics that works for the system. And if user behavior is okay, all good. What kind of events are we talking about? Typically, we can divide those events to stop factors and rules. Stop factors meaning that if event has happened, that's the end. That means that user is malicious, obviously, like 100%, like 99.9% chance that the user is malicious. For example, the list of events will be different in every system, right? So when I say you that when we detect jailbroken device or rooted Android device, we believe that user is malicious. This can be true for your system, or it can be false for a system. So list of events and reaction depends really on your system, on your risks and threats and like security guarantees you want to provide to users. But for example, things like invalid application signature or like failed device attestation, these events can be pretty good indicators that something fishy going on. Maybe that's not a normal user, maybe this is some curious attacker trying to understand how application works. At the same time, with some events, we cannot be so sure. For example, application reinstall. Normal users can reinstall application several times. Where is the limit, right? So what we can do, we can calculate how many times application was reinstalled during some time frame, and depending on our system again, put some limit there. So what I'm trying to tell here is that in this example, cryptography is used to protect the models itself, right? But the good idea is to prevent sending models to users that we believe are malicious, so they don't even have a chance trying to brute force, trying to break our cryptography. Another approach here, as we're talking about mobile applications, is remote device attestation. You probably know that Apple have Apple Device Check framework and Android has Android Safety Net framework. Both of them, they're different, but the idea is the same pretty much. When application starts, Apple or Google can tell you with some guarantee that application was installed from original like App Store or from Play Market. And if application was modified, in terms of developer signature, and the application sends that request to your backend, and then you use your data to analyze, do you trust this application or not? Obviously, remote device attestation can be abused, right? So it's not like single tools that we can rely on, but it exists, and these frameworks exist, and they are very useful when you deal with a lot of fraud and when you deal with a lot of cloned applications. Like typical fraud, when your application gets cloned, just changing some colors, using pretty much the same name. And my favorite is when they clone application, but still use your backend as a processing power, best of the best. I mentioned reverse engineering, and I just want to make a link to OWASP MSVS reverse engineering chapter. I won't dig into details. If you're curious about reverse engineering and anti-reverse engineering things, just check out OWASP MSVS and MSTG to find the security requirements and to find the advice that you can do to protect your applications against reverse engineering. And last remark from machine learning perspective is that machine learning models, yes, they are files, but they are special files. So we can improve security of these models using machine learning approaches like watermarks, like custom layers, like things that are built into this model. Or we can even make these models very specialized that will work only in our system, right? Only for our use case. So stealing those models and trying to use them for other systems would be complicated, as they can be binded. I won't go here into many details because I'm not a machine learning engineer, but I've learned so many nice things about machine learning when I was doing this project. So yeah, just to wrap up, cryptography doesn't live in a vacuum. When you use cryptography, you should remember about all the shiny traditional security approaches and techniques to use to support cryptographic layer. And you know all of them: application security, API security, storage security, anti-reverse engineering, yada, 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 yada. Defense in depth, a lot of layers. We try to protect our precious as much as we can. And yeah, just to finalize, I really like this quote from Building Secure and Resilient Systems, that any security control, when you build a system, when you design a system, you understand that any security control will be broken. right? It's a question of time. It's a question of 0 days. It's a question of implementation mistakes, yada, yada, yada. Any security control alone will be broken. So your goal is to build a system that has many security controls. It has a design that is resilient. So yeah, if you're curious about more about cryptography and how it can be combined with software, things like application level encryption, things like cryptographically signed audit logs, things like how to build React Native applications better. Check out these links. You will get the slides. You will be able to tap on the links. And let me finish with that. If you're interested in, like, you can follow me on Twitter, on LinkedIn. I share a lot of things about like, cryptography related, very applied, very pragmatic cryptography related things. So yeah, that's it. Thank you.
Excellent. Thank you very much for a fantastic talk, Anastasia. We do have a few questions already asked on Slido and on YouTube. I believe I copied them, but everyone, if you would like to ask more questions, can you please use the YouTube Q&A and slide.do/OWASP link in order to ask questions. I'll read out the questions to you. The question number one was, can you please talk about cell seal method in your sample code? What exactly does it do?
Yeah, let me reshare the screen again. So if you're familiar, thank you for your question. If you're familiar with Lipsodium, you probably know SecureBox. Themis has the same idea. Basically, Themis and Lipsodium have similar age, right? So the similar ideas behind the libraries. So Themis has a similar idea as Secure Cell. And it means that this is like an object, an abstraction that uses IIS GCM inside that allows you to symmetrically encrypt something that you put there using a key that you put there. Very similar to SecureBox in Lipsodium, as I previously mentioned. So basically what is happening in these two lines of code, we created Secure Cell, and under the hood, it uses IIS GCM. Themis is built up above OpenSSL, depending on your system, OpenSSL, LibreSSL, like whatever SSL. So under the hood, it uses OpenSSL. It creates like it's ready to encrypt data with the key you provided. And the beauty of Themis is that even if you provided, in this example, we use a key, but Themis also supports passphrase interface. So you can put passphrases directly from users, because under the hood, Themis will use KDF, key derivation function, to create a strong cryptographic key based on the input. So in this line, we prepare our cryptographic primitive with the key. And on the next line, we put encrypted data there and we put some context. You know, IIS GCM is AEAD, authenticated encryption with additional data. Right, so it can use a context, it can use something that you provide during encryption and then during decryption as additional protection. And also IIS GCM is interesting enough because it has this integrity check, right? So basically AUS tag, which is used on decryption to make sure that the data was not tampered. So as a result, you have some encrypted container. In Lipsodium, the same. You have some encrypted containers that consist of encrypted data and the AUS tag, and you then decrypt these things. In Themis example, the salts, the init vectors, all the things important, they're part of this container. So as developer, you don't need to think about them at all.
Excellent. I think we have another question which you can answer quickly. Someone is asking, what programming languages are supported by the Themis library?
Well, there's 14 of them. If you want me to start counting, I will do. So basically,
Excellent. You had a slide, right? So yeah, we can see it there.
Yeah.
So it's, Swift, Android, Java, Kotlin, C, C++, quite a lot, including Python, Ruby, Go, Rust. Fantastic. Excellent.
Yeah. The thing is that like language and a platform is a little bit different things, right? When we say JavaScript is a language, but Node.js and WebAssembly are different platforms. So in terms, I'm struggling with calculating like languages because sometimes they are platforms.
Excellent. I think that slide covers it all. Next question is, how long did it take to implement this solution?
From developer perspective, I don't know, like 2 days probably, because you see the amount of code. They just put these, like from cryptography perspective, the cryptographic layer. I don't know how much time they used to basically from machine learning engineers to, to separate the models. But cryptography was very easy, like 2 days. Mobile developers implemented the decryption part, backend developers implemented encryption part. They created some unit tests and they created some integration tests to make sure that things are working and things were working. So yeah, and then they build one API request, okay, two API requests for key and then for data. That's how, very simple, very straightforward.
Excellent. So that's actually quite good, right? So it's quite a quick implementation for this library.
Yeah.
Excellent.
Designing is a problem, right?
Of course.
Is
There's another question on implementation. Someone is asking, do you have any data or figures regarding effect of this model on performance in context of acceptability to end users or cost of hardware? So does it slow down their phones to make them unusable? Do you have any figures basically on the performance impact?
Yeah, I was trying to answer this question with this slide, basically. So the mobile engineers on that side, they did a lot of tests, and their verdict was that if device was good enough to do CoreML, to do the standard flow processing, and the result output had 50, 60 FPS, then device was good enough to do cryptography. So basically they limited the security control only to strong enough devices, but not because of the cryptography, mostly because of this client-side machine learning rendering thing. So as I mentioned, cryptography was quite cheap. Here, what we are adding extra requests, and we are adding on each side like extra layer of encryption, decryption. That's all. It's not many things going on. If you use on the backend, if you use languages like Python or Ruby, believe me, cryptography is not the performance bottlenecks that you have.
Excellent, thank you. And I see one last question here. I'm not sure if there's more questions, please do ask. Someone is asking, can you talk a bit more about the risks to the encryption decryption process if the phone is jailbroken? I remember you had a slide about jailbreaking. That's probably related. What are the risks there? Is there the risk to the keys being stolen, storage? Can you talk a bit about jailbroken devices?
Yes, so everything you can imagine bad happening on jailbroken devices can happen there, right? So if device is jailbroken, it means that the user, and this is a curious user, they have access to these decrypted individual machine learning models, and they have access even to the process memory, right? So the more defenses we build, the easier these defenses can be like mitigated on a jailbroken device, right? And the problem here in this particular use case, so jailbreaking, it's not always a problem, right? It really depends on your risk and threats. So in this case, the problem with jailbroken devices was that the application is extremely popular. Millions downloads, and with this huge user base, they have a real issue of broken applications and cloned applications. So many people tried to create a clone, and many people were trying to create fake, to create broken Android application and put it to FPGA portal for other users to download, because this part of functionality was on the paywall, right? So they already had cases of users trying to abuse the system. So the goal of building defenses against reverse engineering was to first try to decrease amount of cloned application and broken application already exist, and to make life difficult for people who would like to steal those models. Think about crowdsourcing. Think about crowdsourcing on jailbreaking devices. I like this idea. And of course, all these things won't help against Pegasus. Yeah, so sorry.
Yeah, probably with the latest Pegasus news, everyone is concerned about that. But yeah, I think I like your crowdsourcing idea, which I think is great. Right, I think this is it. I do not see any further questions. So yeah, there's just thanks. Thank you for a very interesting presentation. Many thanks, Anastasia. Right, let me now share.
Yeah, so yes, thank you everyone, and you know what to do, just put likes on this YouTube stream because we want more likes for OWASP London videos.
Excellent. And again, just to remind everyone that you can use YouTube chat to ask questions live and also use slido.do/OWASP system to ask further questions. Now it's time for our second talk, and that's a talk, how to be better at InfoSec, 10 lessons learned from moving from the dark side to the light. And the speaker tonight is Mark Stamford. Mark is the founder and the CEO of OccamSec. Mark started hacking things from the age of 11. Eventually, he turned his interest in security into a career, and he was exposed to some of the earliest days of corporate espionage. Prior to founding OccamSec, Mark worked at KPMG, where he was conducting penetration tests and identifying global threats for some Fortune 100 clients. And then he moved on to becoming a director of threat and vulnerability management at UBS. And then he started his own company. Welcome, Mark. You have the screen now. Please share your screen.
All right. Thanks a lot.
Welcome to OWASP London.
Thank you. Thanks for having me here. I will share my screen and get this show on the road. All right, can you see my screen? Okay, cool. So yeah, this is a summation, I guess, of almost an eternity in information security, not quite, but it does feel that way sometimes. And I suspect at times it will sound like I am an old man yet in a cloud. My apologies, although we do have the same hairstyle at this point. As is customary in these things, there is a disclaimer. The problem with the disclaimer is I work for my company. It's my company, so I guess my views are my company's views. But there are going to be some generalizations here, so please don't hold me to the fire too much on everything here. It's just, these are my general views of things that I've picked up along the way. So this is the obligatory bio slide. I was born in North London. There's a note there about my accent going astray. So I'm actually in London right now. I live in New York. I have been asked at least twice a day where I'm from. I was born in North London. I lived in London till I was in my 20s. And then I went to New York in 2001 when I was hired by KPMG. The interesting things is my years of using computers to do more interesting things. I mean, the world was a different place back then, right? I mean, when AOL came out, it was a big deal. My first computer over there was a ZX81, which had 1K of memory, which is probably less memory than this bottle of water actually has. And I think I was lucky in my career, actually. So when I went into the private sector working for CMC, that was the early days of CMC Markets. So it was a lot of make up everything. It really was my MacGyver job. My first day, I had to make 50 network cables. My second day, I had to deploy a firewall. The third day, I had to become a DBA for SQL Server. So there was a lot of different stuff there. KPMG put me on the front line of dealing with lots of different organizations, seeing what their needs were and how to help them. And it really was a baptism of fire in terms of you must make money in this because otherwise the people I worked for would fire you. So that was good. UBS, I'd moved up the ranks there. So UBS gave me an exposure to the politics of corporate life, information security especially. So I think that those 3 jobs gave me a good background. I started my own company in 2010. And then, my goal is to save the world and get the job done, which is going to come in 3 years' time, hopefully. So that's enough about me. And really what I want to talk about is just provide some stuff that would have been useful if someone had told me 15 years ago, 20 years ago. It might have saved me some time. It certainly would have helped me to keep my hair, because when I started this, I had far more. So that's my plan. I think everyone, at least in operational security, would agree that it does feel like the whack-a-mole game most of the time, like you are constantly responding to incidents, putting out fires, dealing with auditors, compliance requirements. All these things are all being thrown at you all the time. So again, hopefully there's going to be some information imparted here that will make your life easier, maybe. So I guess the first lesson from all this is that security is really complicated, right? And the reason why I stress this at the outset is I am constantly running into people and vendors and everyone else who's going to tell me how they can simplify the security landscape. They have this tool that will save the day. You do this thing, it will work. And none of it ever works. And the problem is, and we'll touch on this later in a different slide, it's just there are so many different variables at play. There's so much that can impact the security posture of an organization that anyone who tries to say, this one thing will solve the day is just talking out of their butt, really. And because it's complicated, I think it's very hard for people who are in the field to really feel like they're achieving something a lot of the time. I think that there's so much to learn here. There's, when I first started, there was just breaking stuff, right? So you would do some reverse engineering, you do some network work. That was about it. Application security really didn't hit the sort of mainstream until sort of like the late 90s, I guess. And then the cowboy hat books came out and suddenly everyone was on security, applications security. And then that's grown and grown as applications have become like the mainstay of the world, right? But that's a massive area to deal with, right? I mean, there are so many different application stacks out there. The cloud has come along, which has made this more complicated as well. So it's really tricky. And I think if you embrace that it's tricky, you might not lose your mind so fast. The second slide here, lesson 2, right? So mostly useless things. This is where I have the unfortunate habit of starting to get myself into trouble, right? There are things that we have to do, that you're going to have to do, that you do, that you probably think are useless. And if you don't think they're useless, they may be useless. But we have to do them, right? Antivirus is always easy to beat up on, right? It doesn't really do that much these days, to be honest. I mean, it does. I mean, there are endpoint solutions which now do some more interesting things. But for a long time, we had to install antivirus everywhere because that was a requirement. Security awareness training, I have a particular beef with because it's pushed out all the time. I don't think it works. I've seen it fail more times than I've seen it work. I think that the underlying reason for that is that security awareness tries to teach you sort of logically what you should do to stay safe, right? So don't click on a fish, don't do this. Whereas the stuff that's attacking you, social engineering attacks, that kind of stuff, is really going after those more base emotions, right? So love, greed, that kind of stuff, that's what you're targeting. So having a sort of pretty poster and a mouse mat and a slideshow you have to go through is just not going to compete with thousands of years of human evolution. We have done various assessments where we've broken into places simply by making sure that we blend in, which really at that point was about wearing a camouflage baseball cap, which is the legendary story as told by Davin Bateman, I'm sure at some OWASP meeting somewhere. Vendor reviews, I mean, it's always kind of a window dressing assessment there, right? You'll look at the certs they have, you'll send them a questionnaire, they'll reply, everyone does this dance, and still they all get hacked and we lose our data and everyone sort of sits around going, what happened there? The problem is as well, because those vendors, their environments are complicated as well. So they're not static either. So there's constant change there. Black box testing. I was a penetration tester by trade. Back in the day, we used to do a lot of black box testing. You would basically just be told, go and test this client somewhere, find them, break it. The problem is, firstly, that, well, not firstly, the problem is it's a waste of money to do that, right? For the most part. So if you are someone who is a buyer of penetration testing or any kind of assessment that could involve black box testing, I think if you pay someone to go and find your IP addresses, you're just wasting time, because whoever's targeting you is going to find your IP addresses, right? They're going to find where your application is. So just give the people doing the testing, this is what I need you to do as the target. You'll have a much more effective use of the resources you've allocated to doing that test. Compliance is this thing, again, that we have to do. Compliance is good in some instances for setting a baseline. I think, though, that there are lots of organizations that just rely on compliance for their security posture, and it never works. I mean, the simple reason why is, if there is a checklist that you're using to build out your security program, the people attacking you can download that checklist as well. And I believe T-Mobile was PCI compliant. So anyway, I'm reviewing threat intel. Threat intel is this other area that we have this sort of love-hate thing with. It tends to create a lot of noise. Most people I talk to about it, it's very non-specific. It really doesn't get into the weeds and give you the information you know to take action. It will just sort of be, there is some ransomware, it attacks Windows. Cool. I'm not sure if you're really going to, spin up a lot of resources to deal with that, right? So threat intel right now, in my opinion, is this sort of vague notion that just gives you a lot of data, a lot of noise, but there's not really useful intelligence that you can act upon in there. But nonetheless, we have to do most of these things, right? And I mean, a lot of it is done as a CYA exercise, I think, which is okay, right? You need to have done those reviews to make sure that if that vendor does get compromised, you've done your due diligence to a certain extent. So you can say, yes, we did this. You need to meet compliance requirements, because a lot of those are regulatory and so on. So we can't escape these things, but I would raise question marks over their effectiveness. The next lesson I think is really important, actually, is auditors are not evil, right? So anyone who is in any position where you've dealt with auditors, at some point you probably wanted to throw something at them. And I think that a lot of this is due to this antagonistic relationship that develops between auditors and information security people. But there's a flip side, right? If you can do this the right way, audit will actually help you get stuff done. So if you can get audit to agree with you on this new whiz-bang security project you need to do, audit typically has the clout to sort of go to the board of your organization and say, we should do this. And it tends to be done, right? It's like magic. It happens. Though it happens all the time. I've seen it happen all the time. I'm sure there are some people who dispute that, but it really does. Also, your boss will be very happy if you work well with audit, and you might even get a promotion. It's cool. If you work against them, what will invariably happen is you'll create problems. And unless you can justify the reason for those problems, you'll probably lose your job at some point, right? One caveat to this, though, right? Sometimes auditors do ask ridiculous things. There was an auditor that I had to deal with once who insisted that we have 100% patch deployment and 100% AV signature deployment within 2 weeks of a patch or an AV update being released. This was across 240,000 systems spread across 63 countries, with a lot of people who just didn't switch on their laptops for a while because they were off doing business development work. That came to a head. There was some interesting cursing that occurred on a phone call. And ultimately, it was agreed that we didn't actually need to meet this ridiculously unobtainable target. So there are some exceptions. But really, if you can work with audit, you might have a happier life. One for the penetration testers, right? Don't just rely on tools. Tools have kind of become the be all and end all of so many penetration test projects these days. The problem is that I think that, firstly, there are a variety of problems that they can lead to, right? So they can cause outages, right? You can't scan everything with Nessus. You can't scan everything with Nmap, right? If you're doing an assessment, right? Certain things are delicate and will break. Printers and Nmap are a legendary issue. Nessus and many things is an issue. AIX stacks used to fall over with Nmap scanning. Application security tools often fire, have been known to create so many emails on the back end that the marketing person comes in on Monday and screams for blood, right? So you can't always just fire the tool at everything. They do create a false sense of security, right? Vulnerability scanning is not penetration testing. If you're doing development work, running a quick scan probably isn't going to be as good as a decent code review. So it can lead you into this trap where you believe, hey, we're safe because we ran a scan, or hey, we found no issues, this client's cool. Also, you'll probably end up being out of a job if all you do is run tools, right? Because you can automate those, right? If you can press, click on a tool, a machine can be told to press click on a tool. I think what's really useful, and I think what actually has worked for a lot of the really good penetration testers that I know and have known, is to understand the fundamentals, right? Understand how TCP/IP really works, right? Understand how networks really work, how operating systems work, learn to do some programming, right? Make sure that you can code in something, right? Really, if you understand how these infrastructures, architectures work, you'll be in a much better place to then say, okay, I need a tool that does this thing. Go and search for it, or just make your own tool, or just do a manual test for the thing you want, right? So really go back to the fundamentals of how does this stuff really work, right? Also, I think it's good if you roll your own security distro. I have nothing against distros, right? Kali, Black Arch and so on, it's all good stuff. But sort of they tend to just lead to people firing off every single tool they can in their distro against the target, not knowing what all the tools actually do. So the actual effectiveness of that is minimal, right? So install install Slackware, right? And then just deploy to it the tools you want that you find you need, right? You'll learn much more, you'll achieve much more, and you'll be a better penetration tester. Trust me on that one. And yeah, manual testing is cool, right? It's sometimes you do have to do manual testing against these things, right? There's not a tool that's going to solve all your problems. For instance, right now we're doing work against IPv6 environments. Remote host identification on IPv6 is really tricky. So yeah, there's no tool that just pops up and does that, as far as we know, but we are working on something. Lesson 5, right? Don't underestimate the bad guys. I read an article a few weeks ago now that said bad guys are just like everyone else, which is true to a certain point, right? Of course they are, right? The fundamental difference and problem that we always seem to face in security is depicted by that chart, right? Bad guys make money by breaking into your environment, by coming up with new ways to break stuff. The good guys typically have to not spend any money on security, right? You will read articles everywhere that tell you how security expenditure continues to rise. That does not apply uniformly as far as I know. There are some sectors where there is a lot of expenditure increase. It tends to be the ones that did very well in the last 12 months. Lots of organizations, though, are still trying to save money, right? So if my profit motivation requires me to break you, I'm going to spend more on security, on breaking security, and you're going to keep spending less and less because you want to save money. Also, bad guys do really cool stuff, right? So we were doing some work, and we came across an interesting occurrence where a bad guy had submitted a vulnerability that had a CVE assigned to it. And the reason this was being done was to fix something in the code so that the other exploit they actually had would work better, right? That's original outside the box thinking, I think. So using the CVE system against itself to help you exploit something further along the line. That happens a lot, right? Again, because these people are working to break the things that we're building, right? Because that's how their business operates. So I think you underestimate them at your peril. I think that if more security people could really spend a few minutes thinking actually like a bad guy, rather than just, well, I went on this course and I read this book and and this is what they do. Because there's so many different ways to attack a target that you really have to try and say to yourself, how would I do this if I had no holds barred, right? I was talking to someone earlier and it kind of came down to the easiest way for me to get a password really would be to put you in the trunk of a car and hit you with a crowbar, right? Can't really do that, right? But I could. But if I really wanted to breach an organization, that would work, right? But you would never do that during an assessment, right? And rightfully so, because bashing the CFO with a crowbar would be a bad thing. But yeah, just don't underestimate them. So next, right? One size never fits all, right? So every organization really is a beautiful and unique snowflake, contrary to sort of, paraphrasing Tyler Durden there, right? And the reason is for all those things listed in that yellow box, which I'm not going to just read out, all those things and more create your environment. And your environment is different than the other environment. And what we see a lot of times is someone will succeed in an environment and they have what they call a playbook. And I hate doing air quotes, but a playbook. And they will take that somewhere and they will deploy it. And it won't work, right? And it won't work because they haven't taken into account that this new organization is different than where they were. If you take a really simple organization, right? If you have 10 employees and 10 workstations and they've each got different applications configured on them and they're using different cloud services and there's, and they're a financial services startup, right? They're going to have a different structure than a 10-person manufacturing company that's producing some sort of new widget, right? Different applications, different people, all these things, right? And then you bake in the outside world, right? The economic environment, what countries you operate in. If you operate in Europe, you probably have a different threat profile than if you operate in South America, right? You're concerned with different things, different regulatory requirements. All this is coming into play, right? So if you go in saying, hey, I really kicked ass in my last job because I did this great thing, I'm just going to go do it over here, you're not going to win, right? It's probably not going to work, right? No matter how good you are. So I think that you really do have to take into account that every organization is different. And that's okay, right? Going back to it being complicated, it's okay that everyone's different and you have to tweak things around. The sort of core things are still going to stay the same, right? Like right now, you're going to do, secure development, you're going to do vulnerability management, you're going to have network security controls, you probably have a monitoring system. Those things are going to be the same, but how it bubbles up is going to be different, right? Everyone else doesn't suck, right? This is something that I guess I was part of for a long time, actually, and I suspect sometimes I still fall into, right? Information and security people especially have a habit of saying everyone else who doesn't know what they know sucks, right? And it's just ridiculous, right? I think that if you judge someone because they don't know how to do the specific thing you do, you are missing an opportunity there, right? All those quotes, for the most part, are real, right? The Star Wars one is one that we use at work a lot, actually, which is kind of an outside one. But if you think of the Red Team one, right? Red Team is this wonderful jargon now that just means different things to different people, right? And people will argue that their version is correct and your version is wrong. It's physical, cyber, social, blended operations, it's APT simulation, it's whatever it is, right? All those things have been posited to me as red teaming, right? And then people will dismiss the person who gave them the other definition because their definition is not the one they've read in the book or they saw a tweet or something like that, right? It's kind of crazy. It's pointless. I think that if you can accept that everyone does probably know something useful, you will have a much better time. I was talking to our senior dev the other day, and he said one of the good things that he liked about working with us was that we're not just constantly saying to him, this is how you should do this thing, right? It was more like, how would you do it? What could you do, right? We all have our ideas on what is the best way to do something, what you should know, what you don't have to know. And usually it's partially right. I'm extremely lucky. I get to work with a lot of smart, different people who come together in a way that I don't think would pass a lot of corporate screenings. I think that we have this really unique, talented collection of misfits, right? And I think that that's what you need to cultivate, right? You need different people bringing in different ideas, right? I have seen project managers do fantastic social engineering work because they're just like, this is what I'm going to go do, right? I have seen penetration testers, have really great ideas on things that have nothing to do with penetration testing, right? I've seen people who aren't even in information security give you really great ideas. So try not to believe that you are the best in the world at this, because you're probably not. And if you can write a useful program in Molvolge, that would be really cool, but it's really hard. So good luck if you can, though. So the next one, I think, I'm trying to get through this because I'm aware of the time. So the first sort of unfortunate truth, I think, in the last 3 slides are sort of like the big slides. Security, information security right now really is, it's very much driven by money, right? Across the whole board, right? And I think in my sort of synopsis for this, I talked about like the endless hype and bandwagon, right? So 20 years ago, information security was this minor blip on the IT landscape, right? I mean, we've kind of done it. I was lucky and I got into it early, but it was nowhere near the juggernaut that it is now, right? And it's a good thing in a way that it has this support. It's good that we have so many great people out there doing really interesting stuff and starting companies and doing projects and making stuff open source and all these great things, right? But what's also pushing it is this endless quest to for more and more cash to be made, right? And the problem is, it's really weird, right? It's created this really interesting, odd space. And to be honest, before I really started running my own company, I really had no idea of quite how crazy it was, right? So if you talk about pay to play, there was a project once, a long time ago now, where we had this really interesting piece of actual threat intelligence, targeted threat intelligence against specific members of an industry. So we went to a intelligence sharing group and said, hey, we want to give you this data that you can share with your folks, right? You don't even need to say it's from us. And I remember having a phone call and being told if I paid $50,000, I could speak at a conference and share this threat intel. And I remember sort of saying, well, wait, your objective is to disseminate useful information to your members, right? So I'm trying to give you this stuff for free. Yeah, but if you pay us 50 grand, then you can talk about it. And that happens time and time again. Like I used to think that if you submitted a talk to a conference and it was good, you would be picked up and have a talk and it would be cool. That's not really what it works a lot of the time, right? A lot of the time it really is pay to play, right? I know because I've paid to talk at conferences now. And it's just kind of, so that is what's driving a lot of this. There is a massive investment industry in information security, right? There was an interesting article on the VentureBeat website 2 weeks ago now that someone sent to me, which was basically InfoSec is on fire, and venture capitalists don't care, right? And the way it's kind of playing out is there's money being pumped into Series A rounds just to get to the Series B round, so you get bought out, and then so on and so forth. I knew of a company once that got $5 million of funding because they wrote a really nice PDF on what they were going to build, and that was it. And they didn't have any other experience, but they had a good connection, and they just got money, and then they grew and grew and grew, and then they collapsed, right? So money really is driving a lot of the good we see in security, but it's driving a lot of the bad. And this is, I guess, where I sound a bit like an old man yelling at clouds, right? But typically as well, what happens is a company will do interesting things, will grow and grow and grow, and then it will either get acquired or it will have an IPO or something like that, right? And then what happens 9 times out of 10 is the quality of the product will drop, company will become stagnant, and then it will just try and re-energize somewhere along the way, right? And the hype around this is crazy, right? Like there really isn't any AI in cybersecurity that actually does anything useful. Sorry to put that out there, but it's true, right? There's a lot of statistics at scale, but there's not a lot else, right? So I think that if you can sort of work out the good from the bad in that will certainly help you navigate what's going on. And if you have a cool idea and you get funding, fantastic, make it work, get it done, right? That will be cool. So that's that one. The second unfortunate truth, right, that I really have come to learn from doing this is really just, is depicted there, right? You don't have to be the most secure company, right? You just have to be more secure than your competitor, right? Unless there is a specific targeting of your organization, this other person is going to get hacked, right? They're going to get breached, not you, because they're the easier target, right? If I am looking to steal information on widgets, I will go after the easiest target, which again is what happens across most facets of human existence, right? We tend to take the easiest road, right? And I think that what we're seeing is this process actually accelerate now. So if you look at different industries, if you're in financial services, you're one of the fastest runners right now, probably, right? And if you're in big tech, if you're in industrial, healthcare, education, you're maybe not the fastest runner, right? So if you're in those industries, you face this problem where you are an easier target, right? So you have to do things smarter and better and take account of everything else that we've been discussing, right? Because you're probably not going to catch up to those fastest running industries anytime soon. And if we go back to the previous slide as well, it looks from a lot of places like this fragmentation is only going to increase, right? So the companies that spend the most will be the fastest for the foreseeable future because they can buy every tool under the sun and they can hire good people, right? I mean, information security salaries are ridiculous. Take it from me as someone who talks to people about their salary requirements, right? Because there's a shortage, right? So there are moves being made to create educational programs to bring about, a broader number of folks in InfoSec, right? But that's going to take a while, right? So yeah, it's just, this is something that we're going to have to deal with for a while. And the final major lesson, right? And this is the most important thing of all. And this was also discussed in Anastasia's slide as well. She mentioned about business risk. If you can speak business, you'll win at whatever it is you're trying to do, or at least you have a better chance, right? If you can explain the information security risk, the issue, the finding, the project, whatever you're trying to do, if you can explain it in a way that the business person, which really is anyone who's not in InfoSec or in IT, right? You can explain it to them in a way they understand, you have a better chance of success. And you may think that that's not true, but it absolutely is true, right? So I remember, for instance, being in a meeting where there were two proposals being made. Someone wanted $10 million to create a new investor media center. And then there was a request for $200,000 for vulnerability scanning stuff, right? Which was a good discount, actually. The $10 million investor pitch was approved in about 4 minutes. The vulnerability management pitch had to go through 3 iterations, 2 different CISOs before it finally got approved. And we see this again and again, right? People don't put what they're trying to do in the language that the person they're talking to understands, right? If you find a vulnerability in an assessment that you think someone should fix, if you just say, if you execute this, exploit, if you exploit this vulnerability, you'll breach this system and you can be the main admin, most people who are outside tech are just going to be like, whatever, right? What does this really mean? If you say, and you can destroy this business process, that's a far more, obvious thing that someone understands to fix, right? And context is everywhere. I was talking to a CISO once of a Las Vegas casino who mentioned that there was this penetration test that was done. The pen testers did this really great thing where they were explaining how they were going to mess with the firmware of a slot machine. So if you put in a coin and press the button, it would pay out. And they thought this was the best attack ever. And they got laughed at because it was like, well, you haven't taken into account the context of this environment, right? Firstly, if you get the jackpot on one slot machine, okay, so what, right? That's not really going to make a big deal in the scheme of things. And secondly, you're going to be found out because you haven't considered how the environment really works, right? Lights normally go off. There's noise. There's all kinds of things when you win a jackpot, right? The machine just doesn't spit out the money, right? So I think that the more you apply context to what you're doing, the more you understand business, the more likely you will be to succeed, right? And I think, for my own career in information security, right? I think that that's probably been the best weapon or best resource that I've had, right? Is the ability to say, do this because this is how it impacts your business. This is how it will save you money. It's probably not going to make you money. There's not a lot of security things you'll do that will actually make someone money, but you can certainly save them money, illustrate dollars and cents, pounds and pence. This is how this is going to work, right? So really do try and, understand this. And to do this, really, you're going to have to just go and talk to business people. Find out what your organization does. What does it really do to make money? Whenever we do an assessment, right? Whenever I've talked to people about assessments, sort of the first question, maybe the second question is, what's your worst day as an organization that could be realized by a cyber attack, right? Which is you really explain to me how someone could trash you via a hack. And that's what I need to focus on. There's no point me trying to hack some random box if I can't get anywhere in your network and achieve that objective. So yeah, really keep that in mind. A bonus lesson is just, certifications are really good, especially when you're looking for a job. Absolutely get a certification, right? Especially in this day and age, because it will get you through that initial HR screening. I've just learned to be wary of anyone who has lots of certifications, because the question invariably comes up like, when have they actually done any work? Are they just studying for exams all the time? So certainly do a cert here or there. Certainly do a cert. It's terrible English, actually. But yeah, just be cautious of someone who has lots of them. That's a bonus lesson. And finally, I realize this is a bit of a sort of self-help slide, but do try and be yourself in this, right? Everyone has commitments, right? I put buy cat food in there. I don't even have a cat, but everyone keeps talking to me about cats for the last year. So I believe they are quite popular now, more popular than they've ever been. And, I've had discussions with people who are still in the weeds of InfoSec, where they have talked about, am I selling out? Am I doing the right thing? I feel a bit skeezy doing this, right? And I think it comes down to sort of like a personal choice, right? You don't need to do that. You can sort of push out, this is what I believe, this is what I think. Feedback from across the board now is that there is this kind of information security fatigue that's set in with everyone who's not in the information security industry. And the reason is that, again, we're 10 years, 20 years in, and the same crap keeps happening, right? We still keep having the same issues, right? And you can argue about, it's in its infancy, it's immature and all this stuff. It doesn't matter to the end user, though, right? Or the person on the other side of the table, right? It's no good to sit there in front of some organization that's just lost its IP and say, well, the industry is in its infancy, so you have to expect this, because they're just going to be really annoyed, right? So people are starting to really require, and really respond well to just honest feedback, right? Honest answers, right? Tell me what's going to work and what's not going to work. And if nothing's going to work, then tell me, right? You can't push back on some of those things, right? You're going to have to do compliance. You're going to have to deal with all those other things that we discuss, right? But I think that if more people do sort of stick to their guns, and you do have those conversations with your customers, whether you're a consultant or an operational security person or a dev or whoever, right? And say, this is the way to do this. And if you put it in that right context, I think you can probably maybe sleep a bit better if that's your thing. And if not, you can play politics. That's cool. And everyone, I'm sure you'll succeed and have a nice day. But, I think that there is the potential, and it is growing, and there is a demand for people just to actually, do this in an honest way now. And that's what I believe is gaining traction. So I think that's it. I'd like to thank OWASP London for letting me talk. Again, I am from here, so it's actually quite nice to come here and talk. I will now return to New York, and my accent will get more confused. But yeah, thank you all. I hope this was useful. Yeah, it's cool. Thank you. Thanks a lot.
Oh, excellent. Fantastic. Thank you very much for a great talk, Mark. Certainly learned a lot, and in your 10 questions to be asked, some very, very interesting points you discussed there. There are a few questions from the audience. So question number one, what would you say to the CEO of a company who believes that they are too small to be hacked?
I guess my conversation with them would be, what's your worst day, right? I mean, is there something you do where an attack could actually harm you? Because some organizations, when you really do the whole threat profiling thing, some organizations aren't probably going to be hacked, right? Because it is a numbers game as well, right? So I think that if you have a conversation and say, okay, what do we do as a business? How do we make money, or how do we get funding, or how do we get whatever? Is there a way that could be taken down and we could have an issue? Yes, well, then we might be hacked. Let's go and do some investigation and see if anyone actually targets our organization. No, there's no way it could happen. Then fine, don't do it, right? I mean, if you're in a company that sells, I'll tell you what, right? I was at a conference once where someone said to me, why do we have to worry about this information security stuff? And we had this whole long conversation, and then they said, but we keep all our files on paper in cabinets, and there's no computers. And it was like, okay, well, then you don't have to worry about this, right? Why did you make me talk about this? So I think, yeah, ask them, how do we make money? How could that be impacted? Then let's have a conversation.
Excellent. Thank you, Mark. The next question is, Mark, what is your worst security advice for organizations?
Good question. I guess, the worst, I think you should really avoid believing the hype on information security, right? I was starting to sing "Don't Believe the Hype" there in my head. Sorry, because I was listening to it earlier today, actually. I think that if you if you succumb to the way that the industry has turned, right? And again, this is where I sound like an old man yelling at clouds. But if you sort of give into it and accept that, oh my God, there's this AI tool that's going to solve all my problems, I'm going to deploy it. It will cost you a few £100,000 minimum price, as far as I know, that's what I'm thinking. It has a really cool GUI, but doesn't do anything, right? So just don't believe the hype, right? Understand again, like what's feasible with technology, what's my risk profile, what should I, that's how you make a decision. So I think that's important. The other worst security advice, I think, would just be, again, to go back to that, like, here's my playbook, here's what you do, go do it, because that's not gonna work, right? So don't try and do it just because everyone else is doing it and because it worked for you before, right? I think those would be the main ones. I guess, I mean, I could make jokes about Microsoft, right? But I'm not gonna do that because that's a bit old school now. But yeah, I think, yeah, try to, don't believe the hype. So the worst advice would be believe the hype and buy whatever is being recommended by some advertising group. I'm going to be sued out of oblivion.
Fantastic. Next question is, Mark, what do you think about OWASP SAM, the software assurance maturity model? Do you find it useful for organizations to understand their security posture?
Anything from OWASP is fantastic. That was it. That was my answer.
That was it. Good.
That was
good.
It. That's my
I think there's a comment on the question on the certification slide that you had. There is a lot of bad talk about CISSP certification on Twitter these days. What do you think about CISSP or CISP? How some people pronounce it. And do you recommend it for your pen testers or just for pen testers in general?
I have to give you the truthful answer here, because if my pen testers are listening and I give you a fake answer, they'll call me up on it. So I would only say I used to have a CISSP, but I let it lapse. I would say that I'm not sure about for-profit certifications. I think the CISSP is probably a good baseline of useful information for a security practitioner. I don't think it's particularly useful for penetration testers. I think there are other certifications, like the OSCP is a much better certification. I think that, yeah, I mean, something like that is actually targeted on, like, this is what you do for offensive security work. That's much more useful. The CISSP is really good if you want to be kind of like an all-round security bot, right? And if you want to become a CISO at some point, you probably need it, unless you have really a large chunk of experience. But I don't think it's good for penetration testers.
Excellent, thanks. The next question / comment is probably about your strategy conversation, one of the slides. Culture eats strategy for breakfast. What do you think?
I guess maybe. I mean, if we're talking about organizational culture, right, the strategy that you're proposing should kind of take that culture into account, right? So if you have a culture that's very open and everyone's doing all kinds of, fun, interesting projects, right? Having a strategy that's like, I'm going to lock down everything and no one can do anything, you're going to fail, right? By the same token, if you are in an organization like the military, which is very regimented, people follow orders because that's how it has to function, you can probably have a strategy that's pretty rigid in certain points, right? So I don't think it's so much culture eats strategy. I think strategy has to take culture into account or it will fail. Again, every organization is a beautiful and unique snowflake.
Great, thanks. The next question is, Mark, do you have any specific recommendations where the potential bad guys are actually state-sponsored groups, whether for intellectual property theft or denial of services attacks for DDoS?
That's a good question that I'm not going to delve into too much of an answer on, which some people will say, haha, because he doesn't know anything. Because again, go back to the slide where everyone thinks everyone else sucks. Almost certainly there are state-sponsored actors, right? I mean, this is beyond debate, right? I think DDoS is kind of a boring thing to do if you're a state-sponsored actor, right? It's usually done as kind of like the end phase of something. So I've stolen all this data. Now I'm just going to crash this out of existence, right? IP theft is a big thing, right? And I mean, you know, there's various moves being done, certainly by Western countries to produce some kind of framework on how they deal with IP theft. There was an article that came out 2 weeks ago on the rise of competitive intelligence, right? Competitive intelligence is businesses, you know, trying to get information on each other, which is just an offshoot of nation states trying to get information on each other. So I would say at a high level, there absolutely is nation state sponsored hacking going on. I would probably say it happens. Everyone is doing it, right? I'm sure the West attacks the East and the East attacks the West, right? It would be naive to not say that. But yeah, I don't think they do a lot of DDoS though. There's been some interesting stuff though, right? I mean, there was the story 3 years ago now, where as far as everyone knows, the Chinese did some BGP hacking. BGP is still this really fun thing that you can play around with. They messed with BGP and rerouted a chunk of the internet for like 45 minutes, right? And then there's all the traffic you could siphon off of that, right? That was clearly a state-sponsored action, right? Although it gets kind of murky, right? Because, and this is all sort of public stuff, right? So, I mean, if you look at Russia and China, and Russia and China mostly, a lot of it is being done by groups, right, who may or may not be state-sponsored. China's changed a little bit. There was a book that came out about 15 years ago that went through sort of like what the Chinese state-sponsored hacking organizations look like. That's certainly changed right now. But it's tricky to tie that back to a nation state. But I think some of it is certainly being done by nation states. And I think in the West, governments run their cyber groups, right? So they're not outsourcing it to other people, right? I mean, I'm sure they are in some places, but as far as we know, most of it is done by these state groups, right? So yeah, there is, but hopefully not a lot of DDoS. And if it gets to a DDoS point, I think we're all in trouble, because I'm sure all the big players have massive DDoS capability if they want it.
Excellent, thanks. And one more question I see in the queue. Mark, given a second roll of the dice, what would you do differently in your career?
I think I would read a lot of books about not losing my hair, actually, because I think I could probably sell more work if I had more hair. But I think from a professional perspective, I don't know, actually, like my career is pretty cool, right? So, I mean, I was born in North London, right? So I grew up in Bounds Green and then Tottenham, right? And then I got this lucky break at CMC Markets. They gave me this job that allowed me to really be at the forefront of internet work as it was back then, and information security. And then I was lucky, I got hired by KPMG. They shipped me to New York. That was really cool. So now there's this 27-year-old kid from Tottenham who's running penetration testing at KPMG in New York, right? So I think for the most part, I don't think I would change it. I think actually the one thing I probably would change is I would start a company earlier, because starting a company is a lot of fun. Sometimes it's really not a lot of fun. But I think, yeah, if I could, I guess, go back, I would have started my company 10 years earlier, right? When information security was still in its infancy in many ways. Kind of like when Foundstone was made, right? For those of you who are old enough to remember that. So some guys at EY left EY, formed Foundstone, and then Foundstone got bought by McAfee, and ISS was made at the same time, right? So ISS was started down in Atlanta, and then that got bought by IBM. So I think if I could go back, just because then I'd have more time, right, to do stuff. I mean, I am getting older now, so working really long days is getting a bit trying. But yeah, I guess that's what I would do. I would go back and start OccamSec earlier, right? Other than that, though, I wouldn't change anything because it's cool. Like I said, I'm lucky. I get to work with a lot of really good people. Both, my team at OccamSec is fantastic, and I get to work with a lot of good clients who do interesting things. And I just know a lot of cool people in this space. So yeah, I think I think my career was cool actually. I think. But not the hair loss part, because I can see myself and my head is massive. It's like a bowling ball. Seriously. That's what information security will get you if you're not careful.
Yeah, I think, hair loss affects all of us.
Yours is longer though, so you're okay. You've still got some.
Okay, excellent. Thank you very much for a great talk, Mark.
Thank you. Thanks
fantastic 10 lessons, and I think everyone should watch them. Some really, really valuable information there. Right, okay, I don't think we have any further questions. I think this is it. I'd like to thank everybody and remind everyone how you can follow us and follow OWASP London chapter's events. We have a webpage on owasp.org. You can also follow us on Twitter. You can like us on Facebook, where we also have OWASP London page. We also exist as a channel on OWASP Slack. If you are not on Slack, you can go to owaspslack.com to join us. There is an OWASP Slack invite available also on owasp.org. If you're not a member of Slack, you can join there. We're also on Meetup, which is also OWASP London. And of course, you're watching us live on YouTube right now, where we have our channel, youtube.com/OWASP London, where all the recordings of all the past talks are being published. We're also on LinkedIn. So if you're on LinkedIn, you can follow OWASP London on LinkedIn as well. I would like to say a big thank you to all our chapter sponsors, and would like to remind everyone who wants to sponsor OWASP London, you can do by contacting us, and you can just follow the contact us link on the OWASP London webpage. Big reminder, everyone, that we now have the date for our next event, which is going to take place on October the 7th. And we're going to have Andrew van der Stok, our OWASP Executive Director and the OWASP Top 10 Project Leader. And he's going to tell us everything about the brand new OWASP Top 10. If you haven't seen the brand new OWASP Top 10 draft, it is now available online. Please go to owasp.org/top10 to find out what's changed this year. I would like to thank everybody and remind everyone that the recordings of the talks will be available on OWASP London YouTube channel, and all the slides will be shared on OWASP London webpage under past events. Thanks very much to our fantastic speakers tonight, and stay safe, everyone. We'll be back on October the 7th. Thanks, everyone. Bye.